Good morning, everyone. So, welcome back to a new session where we are going to discuss about the basic framework that makes one AI agent smart. So, that will be what is there, how it will be working as a smart. Because if we are providing the good quality of context, good quality of memory. So when this memory comes, how there are different kinds of memories. So how this memory gets organized. So there one concept comes ontology. And this ontology concept is not too new like the any other things you got talking about any new technology. It is very old. But when these different kinds of how we have to structure, how we have to arrange, how we have to store all these informations, then it came that like no, there is a need of ontology. And now it's like from 2026 onwards, and it is growing. The statistics says that the number of users, the number of companies, and the revenue comes from this ontology engineering or the ontology based systems will grow exponentially, which is within 2030 it will be like multifolded how much is the current revenue the industry is getting out of this ontology uh, based systems, we can say like that. So in that perspective, the basic thing is like that we need to go back to one step behind, and then we will try to understand the four terminologies those we need to understand before coming to this system that we say that how to manage, how to structure this knowledge system. Knowledge means we are talking about memory. So in the first part we are going to discuss about what is the need of context and what is the where these terminologies, for example taxonomy, ontology, semantic layer, knowledge graph, what are they and where they get fitted. And then we will try to understand one example, that is the memory, how to build the memory system, and then how we can build the complete AI agents memory system. Different types of memories are there using this concept, that is the framework, ontology based framework. So let's start the session. So when it comes to building one AI agent, so everyone says that no, these LLMs, in order to fine tuning we need plenty of data, huge of data, and every day, every week a new advanced smart model is coming up by each of these LLM labs, LLM generated labs, for examples like Anthropic or OpenAI. So they are building, they are publishing a new powerful models every week. So what everyone feels like that, okay, we are having the more powerful model, and if we feed enough data to it, then definitely our systems, AI agentic system, will also behave very smartly, and its accuracy will be very much improved, and then will be leading the specific, that product will be leading the industry. But that's not true. So we can say like that, from the data perspective, we are having data warehouses, data lake, delta lake, so many concepts. And from the models types, very GPT's 5.4, then Anthropic's Sonnet, then this FableChem. There are so many powerful models. But what these models, LLMs, we can say like that, they are intelligent. But what will make the exact what the AI agent or the human wants from this LLM, that will make the LLM more powerful, is that context. And context comes from the data or the knowledge, and where this data and knowledge are getting saved into various kind of data warehouse system, and we are having various architectures, data pipelines and various architectures. But all the data present in these data warehouse systems, they can be called as knowledge? No. I'm giving a simple example. So you are going to appear one interview, We have studied everything. We have all the informations about the company where you are going to interview, and all the related that is the knowledge information you are having regarding the post you are going to apply. So when the interviewer asks something, so you have to take the information. You should be able to answer that questions with accurate informations, with relevant information. Instead of that one, even though you are having so many data in your brain, but you are not able to uh, construct your answer in a very informative manner, and the interview is not getting satisfied. So that is not your objective, right? Even though you are having a lot of data, but your answer should be relevant to the interviewer's question. Similarly, if you think about AI agents brain, so AI agents memory, so when the AI agent or the agentic AI systems, one user query is getting hitted into the system, then it goes through the phases of build various kinds of various components. So memory comes as a very vital component of building one AI agent system. But if the LLM does not get any required information from the system, from the memory system, then it generates the response that will be not useful for the user. So in that case, what we say, the model has hallucinated. No, we have not improved the model performance, like that way. But what even though we have applied, we have used the very powerful LLM model, we are having lots of data that we have fed to the model, but still the agent is hallucinating. There we miss something named as context. Context is the same as the knowledge in the real world system. It implies to knowledge in the real world system. So when we say that knowledge, then how the knowledge should be structured. It's not like when the unstructured format of the data is known as data, and the structured format of the data is known as knowledge. So how to make it this data as structure, then we need to understand about this concept, that is the knowledge management system. So when we talk about the knowledge management system, then we are coming to the hierarchy. First is that how a specific information is classified. For examples I am giving, when we say like that, define dog. So how to define dog? What is a dog? If someone asks us what is a dog, then at first we need to understand that, okay, first is that there is animal, then second is that mammal, then it is coming dog, and then one one level down we can say that Labrador or the golden retriever dog. So if someone asks you what is dog, then what you have to say, okay, dog is an animal and comes under the mammal category. One example of dog we can say Labrador or the golden retriever. So this is the classifications that we can say. And this classification is termed as taxonomy in knowledge management system. Okay. The next part, if we go for that one, if we are having some set of information stored, is that one. Okay. Dog hates cat. Okay, and the dog loves the cow, for example. If you have stored that one, then when we put that what is dog, then we can say like that, okay, my dog hates cat, but my dog loves cow. So in that case, what is the one level down with what we have said? We have given the relationship, and this layer is known as ontology. So in the ontology, we have to store different kind of relationship. First is that taxonomy. There we are defining various kinds of classes, entities, and in the ontology perspective, we are defining, okay, what are the relationship between them. Then one more level ground down if we go, then that layer comes that semantic layer. So where in that semantic layer, what information we have to store? It is like that some kind of definitions, some kind of meaning. So various kinds of, if you have gone through the data platform when we are building the data catalog, all those things, Then there what you have to, instead of segregated informations, a segregated information maintained by each business unit of the organization, we will be having one data platform, and which will be having all the informations about the generated data stored in that data platform, and one data catalog layer will be on top of that, which should define each of the data products. So these are all kinds of reports, models, all those are data products. So all those data products information. So what we are going to, what this specific report does, what are the different attributes present inside that one, what are the glossary, what are the terms used inside that one, what are the glossary of that one. So everything we used to manage there. So this is called semantic layer. So when someone asks about some Power BI report, okay, so there what we are saying, that for a specific use case we are managing, we are maintaining some kind of filter conditions, some definitions, some kind of different terminologies we are using. So for that specific report, the definition of sales is different, and for another report the definitions of sales is different. In that case what we say, that separate, if the user query comes, if we are having separate information system, then it gets from which system it has to pick up what is the definition of sales. So we should have a unified layer which will be having all the definitions, meanings of all the terminologies used by all the data products across the organization. So that we say that in data platform we used to maintain that information. So similarly for AI agents will also use the data platform, all these information. So there what we have to do, we have to maintain all these information. So now we have covered all this semantic layer. The next part is that the actual implementation of all these things, that will be done through the knowledge management system or the knowledge graph system. So there we have to put like that, what is the relationships and what are the different kinds of attributes used, how each attribute is related to another attribute, how the what is the definition of each attribute. So everything gets embedded, gets stored and embedded into the knowledge graph. How it happens, let's discuss in the next session. So I was talking about the knowledge management system or the knowledge graph, something I was checking. So whenever someone says that, okay, I'm building one knowledge graph system, knowledge management system. So in that case, immediately the opposite person asks which data storage system you are using, whether it is the property graph, for example, Neo4j, or RDF. So it is not based on the popularity of a specific database. It should be the data storage system should be considered based on the use case. What should be the knowledge graph system based upon the problem statement that we are going to solve. For example, if we are having information that the graph traversal should be there and the complete kind of relationship between various entities, then we need to use the property graph. So what should be the property graph? The property graph, like each node and the edges, they will carry the property of that specific data entity. Property means, for example, if I say like that person is in class node in the property graph or the Neo4j, then what are the different property of that one? You can say like that, okay, ID, person ID, name, age, DOB, something like that information, and those get stored as embeddings in the node itself. Similarly in the edges also. But so what are the real time use cases? When you are doing some kind of recommendation system, when you are doing the fraud detection. So fraud detection systems, what happens? It is like that, if I have done some kind of fraud and I am associated with I am the daughter of my father and my father is the brother of his brother, something like that, and he has some son. So it is going to the third person, the fourth person named as ABC, person ABC. So he is related to me as the fourth hop. It is like a one hop. It's a jump, one jump. It's a kind of like that. So it says like that, okay. So even though I have done some kind of fraud and the person XYG or ABC, he has not done any fraud, but when he goes to apply a loan to the bank, then this fraud detection system, they are having fraud detection system, they get triggered, and they try to find out whether actively he has done any kind of fraud in the past, or possibly he is associated with someone who has already done fraud. So in that case, it will come after the fourth hop, like fourth jump. It will come like that, he is related to me and I have done some fraud. So in that case, what will be happening? So some risk score associated, fraud risk score will be calculated for him, and it will be shown in the systems and the administrator that okay, the risk score for this person is this much. Then the administrator will decide whether he has to approve the loan for that person or not. So this is a kind of relationship. So that person ABC or XYZ is associated with me, how he is linked with me. So these are things. Similarly, in case of recommendation system when it comes that collaboration systems, user based systems. So my preference, what are the different kind of preferences? And if I am associated with in the Facebook, you can say like that, friends, how the friends request come. It is like that in the networking manner. There also one kind of graph runs. So when it happens, it's a kind of relationship networking, how each individual is related to the other. It will give one kind of score. So on top, and based on that only, it suggests like that, okay, the score is this much coming, and this is beyond or this is above or below the threshold value, then he should be sent as a friend request to this person, yes or no. Alright. So these are the things it happens with this Neo4j, the property graph. When it comes to the RDF, that is the resource definition framework. So when it comes to definition, that means we are giving one semantic meaning to each attribute and each entity, each class used there. So in that case, what will be having? We are putting some kind of business rules, some constraints, okay, so that we will be able to understand, okay, what is the meaning of this and where this can be used, to which user this can be accessible. All these informations we can get. So that is called as semantic layer or the RDF, resource definition framework. So general open source tool where we are designing this RDF is a Protege tool. So in our next sessions, we will be doing one kind of use case to come up with this complete ontology model, and this is called the ontology, the complete ontology model. How we have to integrate, we have to do all these kinds of terminology concept we have covered, like the taxonomy, then second is that ontology, then semantic layer, and then final implementation through the knowledge graph. So keep it ready for that one. I will be covering it shortly. So we covered the basic terminologies of knowledge management system, and coming back to the same thing, that is the context that is used in the AI agent system. So when I say that context, it is like a kind of a specific information providing to the user. So in that case, we have to divide, that is, I can say, context spectrum, means what are the different types of context here. So three categories I would like to divide. First is that it is statistical context, second is that semantic context, and third is that logical context. So first is that, for example, if you say like that, doctors and the patient in a healthcare systems, if you, there are lot of informations, lot of document, lot of data present, in fact, in the data warehouse system, with the two words occurring very frequently, that is doctor and patient, doctor and patient. So in that case, it will be, the system will be able to, when we feed this kind of data, system will be able to understand like that, okay, doctor is frequently associated with this patient, then there is some kind of meaning, relationship between these. So what is the number of times it is getting associated, both the terms are getting associated with each other, that is a statistical count, that is a statistical measure, the number of times both terms are associated or the occurring together. So in that case, the system will be able to understand, okay, doctor means patient, patient means something, somehow this is related to doctor, Okay, something, somehow they are related. So that is called that statistical context. We are giving this kind of informations. And the second is that the next step is that semantic context. So when it says that what is that doctor uh, prescribed this medicine to patient, and because the patient was having this disease. So this is a two types of relationships I mentioned here. Doctor prescribed and the patient is having this disease. So what is that? One kind of relationship is coming. So that is naming us, okay, this is a semantic kind of thing, some kind of meaning, some kind of relationship. So this is a kind of semantic context I am providing to the system. The original thing is like the logical context is like that. For example, if I say the patient is having type B, type 2 diabetes. Okay, so the doctor should not prescribe some medicine which will be causing any adverse event for a type 2 diabetic patient. So in that case, there is some kind of logic is available, and the doctor should consider that logic before prescribing any medicine to that patient. So all these informations, how these are getting stored into the system, all those are data, but we are structuring, we are capturing all these kinds of relationships, statistical meaning, all these kind of logical reasoning into our system, and that is becoming knowledge, and in the real world that is becoming knowledge. And when it comes to the AI agent ecosystem, it is termed as context. So now you got the clear picture what is context, why this context is required in AI agent building systems, what's the difference between context and the knowledge, and what are the different hierarchy terminologies we have to adhere, we have to keep building in order to come to the final implementation of the knowledge management systems. So now we understood how the specific information is getting stored into knowledge management system. So but why this is required? Okay, so when you think about this AI agent, you are building AI agent, right? And there are 5 layers of memory that we'll be discussing. But first thing is that user is putting some queries, and LLM agent is deciding, it is planning the next step, what needs to be done. LLM is generating something and coming back to the user as a response. So in that case, how it will get all this context? Okay, it is like for this specific user, what are the different questions it had asked before, to what extent those were helpful, and all those informations it will be provided to the LLM as a context, and then it will take its own engineering inside that one, and final response will be generated. So before that, it should be verified that to what extent it meets the user's need, user's expectation out of for this specific query out of the system. So how it is done? We say that provenance. So that means how each system is, how each information is traced back to some other relevant informations that were provided in the past. So first is that how it will be, how the knowledge is getting stored there. So in order to make one system provenance, that means it is proved that okay, this is the valid information from this, then what we have to do, we have to ask 3 questions. Okay, first is that what is the origin of these informations? Is this information that we are going to share with the LLM, is this information originated from this specific user or any other specific users? And the relevant information, whether this specific information, the second is that whether this specific information provided by this user, it was 1 month old or recently yesterday only. Okay, so someone should be there to update this kind of information. Who is the owner of maintaining this kind of informations? Okay, and the third one is that what is the history? How old is this? Okay, if that, even though it is maintained by a specific owner, but this information came up which was 1 year back, which is not relevant for the user right now at this point of time, because he has given some updated information about his profile, his need, yesterday itself or 1 week back, and that will be most relevant in order to answer this specific user query. So these three things we need to keep in our mind. That is, first is that, okay, what is the source of this information? Second is that, is there any owner who is maintaining the proper relevant information in the system? And the third is that, what is the freshness of this specific information? So in order to make one provenance system, you think about AI agent memory system. We have to you have to keep these three concepts into our mind, so that we can come up with a more working, powerful provenance system.